Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Shifter Stars by Katie Splendor. And here are the rules. We have normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, or boxes, basically. We have shifter lines, where shifters, adjacent digits within the same box. Oh, that's interesting. I don't think this is typical shifter rule set, but adjacent digits within the same box on a yellow shifter line share both parity, even and odd, and polarity, low and high. So the even and odd digits are obvious, right? Because the odd digits are 1, 3, 5, 7, 9. Even digits are 2, 4, 6, 8. Polarity is basically 1 through 4 as the low digits and 6 through 9 as the high digits. You can actually have some differences in polarity depending. Like you could have the entropic line rule set where the polarity would be, the different sets would be 1, 2, 3, 4, 5, 6, and 7, 8, 9. But when you're talking about specifically the shifter lines, the polarity is low digits are 1 through 4 and high digits are 6 through 9. So adjacent digits within the same box on the left yellow shifter line share both parity and polarity. So for example, if this were a 6, this would have to be an 8 because these two digits must share the same parity, which is they're both even, and the same polarity, which is that they're both high. Whenever the line enters a new box, either the parity or the polarity shifts, never both. Shifter lines can never have a 5 on it. So that's the reason why you have high and low digits here. And digits may repeat on lines if allowed by other rules. So whenever the line enters a new box, either the parity or the polarity shift. So for example, you could shift the polarity here, which would be, they would still be even, but then they would be low polarity, and that would work if this, because this would be 2, 4, that would add up to 10, that would work. And this could be similar, right? So it could be 2 and 4 in this way, or something along those lines. Or another thing it could do is it could shift parity. So it would still be high polarity, which means it's 6 through 9, but if it shifts parity, it's odd then. So it would have to be 9 and 7. And that's an example of how shifter lines work. We also have ratio crop key dots, where digits separated by a black crop key dot have a ratio of 1 to 2, and there is no negative constraint there. So for example, if this were a 2, this would have to be a 1 or 4 to maintain the 1 to 2 ratio between them. And finally, we have X pairs, where digits separated by an X sum to 10, and there are no negative constraints there either. So for example, as we used, if this was an 8, this would have to be a 2 to maintain, so that they would add up to 10. And those are all the rules. I wanted to do this puzzle because it's a shifter rule set, which is gaining a little popularity. It's not that common still, but it's an interesting rule set with some interesting implications. Anyways, if you want to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay, so these two digits must be the same parity here. So for this, we have to have a polarity shift between these two digits and these two digits, right? So this is either both low. If this is odd, Hold up. This is in a 1 to 2 ratio. And they're the same parity and the same polarity, which means they're both same, even, and odd, and same polarity. Well, if you double 1, you can't get an odd digit to go to another odd digit in that sense scenario. So it has to be even, even, and therefore it's 2 and 4 or 4 and 8. 4 and 8 do not share the same polarity. One's low, one's high, so this must be a 2-4 pair. So since this is a 2-4 pair, that eliminates 2 and 4 in the rest of, well, 5 can never be on a shifter line. So in the middle central box, where can the 5 be? It has to be here. So this is 5. This 2-4 pair shifts either polarity, which is high or low, so it could be 6 and 8, or it's parity, which would be odd and even. So it's either 6, 8, because you shift polarity, which is the high and low, or it's 1 and 3, because it's odd. So this must be then 7, 9, or 2, 4. Which makes this also 2, 4, or 7, 9. Because, again, it has to be either low polarity and an odd parity, or it's high polarity and even parity. This would then change to a high polarity and an odd parity, or it would shift to a low polarity and even parity. Well, 7 or 9 cannot be next to a black Kropke dot because 7 is double of 3.5, which is not a digit. 9 is double of 4.5, which is not a digit. And if you double 7 or 9, you get 14 or 18, which are not digits. So this can never be 7 or 9. It's a 2 or 4. So this is a 2-4 pair, which makes this a 6-8. Since these two are the same parity, it has to be 6 or 8 here. So this is also 1, 3, 6, or 8 as possibilities here. This 2 and 4 can only be in a 1 to 2 ratio with 1 or 8 because we have a 2, 4, 2, 4 pair already in the row. Okay. This is a 6, 8, 6, 8 pair. So this cannot be even at all. If these were even, it would have to be a 2, 4, 2, 4 pair here, and that would eliminate all possibilities for that cell. So these are all odd. Maybe, yeah. I'm going to mark evens as... let's mark evens as orange and odds as green. So this is even high. This is low even. This is even low, even low. This is odd, and we don't know which one it is, though. So this is 1, 3, 7, 9. This cannot be 2 or 4. These can't be 2 or 4. So okay, where is the 5 in row 3? Can't be on the shifter line. Can't be next to an X, because if it's next to an X, it would have to add up with another digit to add up to 10, and 5 would only add up with 5 to 10, and therefore you'd have a duplicate, you have a repeat in the same column. So this must be a 5 here. Um, hmm. uh, these cannot be high, even, but it could be odd. Hmm. This can't be 2, 4. We need 7 and 9 to be somewhere here, right? They can't be here. Only one of them could be here. So say this was 7 or 9. If this was 7 and 9, 7, 9, the problem is this 7 or 9 that's not in row 3 can't be here, and it can't be here because it has to change polarity or parity here. So this cannot be a 7, 9 pair here. Where are the 7 and 9? Well, one of them then has to be here. And if one of them is here, the other one is here because they're the same polarity and parity. So this must be a 7, 9 pair. So this is even and high. This can go to, this is odd and high. That goes to even and high or odd and low. Same here, 1, 3, 6, 8, 1, 3, 6, 8. So this, because of the 2, 4 pair and the 7, 9 pair, this must be 1, 3, 6, 8, which added to another digit must be 9, 7, 4, 2. Same here, this is 2, 4, 7, 9. Added to this digit, 7 and 9 can only add up with 1 and 3. Since this is 1 and 3 here, that means this cannot be 1 and 3, because that would eliminate all possibilities for that cell. So this has to be a 6, 8 pair. So this is high and even. This is low and odd. We don't know what these are. So one of these two digits is a 3. So this cannot be 3 here. If this is 3, this would have to be 1, so this can't be 1. If this is 3, this is 7. Either way, the 7 has to be... Well, it doesn't have to be here. This can't be 7 anymore. These must go to 2, 4 or 7, 9, right? Because it changed either polarity or parity. If it's both even and high, it must go to either even and low, which it can't be because of the 2, 4 pair there, or it must, so this has to be 7 and 9 no matter what, because we already have a 2, 4 pair here, so this can never be a 2, 4 pair. Therefore, this is 1, 3, and this must be odd and low, and this must be a 1, 3 pair here, because they are the same parity. These are in a 1 to 2 ratio. Therefore, since these are odd, these must be even and high. So it has to be 6 and 8. And the only combination that works is 6 here and 3 here, and this is 8, which makes this 6 and 8, because this is a 1 to 2 ratio. This 3 is next to a 7 to add up to 10. Therefore, this is 9. This can't be 3. This can't be 1 because of the 1, 3 pair in the column. So this is 1. This is a 6, 8 pair here, which eliminates 6 and 8 in the rest of the row. Therefore, this has to be 1. This is 3. This is 7. This 6 and 8 has to be with a 2 or 4. This 1 is in a 1 to 2 ratio only with 2, so this is 4. Actually, we sort of figured that anyways. These must all be odd, but 1 cannot be here. So where is the 1? It has to be here, which means these are the same polarity and parity. So it's 1, 3. This is a 7, 9 pair then here. The 7, 9 pair means this cannot change polarity going from low to high, because then it would have to be a 7, 9 pair, but we already have a 7, 9 pair in the row. So this must be a 2, 4 pair, which means this can't be 4 because of the 4 in the column. This is 2, this is 4. This goes from low polarity and even to, it has to go to an odd, because these are all even then. Therefore, this must be to low polarity and odd. This can be either 2, 4 or 7, 9 here. Again, once again, 7, 9 cannot be next to a black Kropke dot because it's double of 3.5 and 4.5, and doubling it gets 14 or 18. 2 and 4 cannot be next to a 6, 7, 8, 9, so this is only 1 through 5. Can't be 2 or 4, obviously, so this must be 1. Because you have to have the same, either the same polarity or the same parity here. It can't be the same polarity because 6, 7, 8, 9 is already taken, so this must be 1, 3. And therefore, this specifically must be 1 because this must be 2 to be in a 1 to 2 ratio. So this is 4, this is 2, this is 4. That makes this a 3, this is a 1. This is in a 1 to 2 ratio. It has to have a 4 somewhere because 1 and 3 are already eliminated. So it can't be 1, 2, can't be 3, 6. It's either 2, 4, or 4, 8. And 4 can't be here, so this is 4. This can't be 2 anymore, so this has to be 8. This must be 1 and 3. It changes either polarity or parity. It's either 2 and 4, which it can't be because of the 2, 4 already in the row, so it has to be 7, 9. It can't be 7 here because of the 7 there, so this is 9, 7. And I guess we just do Sudoku now from here. This has to be 5 or 6. This is 5 or 6. In row 7. In row 4, we have to have 1, 3, and 5. This can't be 1. This can't be 3, so this is 1 or 5 here. And it can't be 1 here. So this has to be a 5, which makes this a 6, which makes that a 5. This 5 eliminates 5 here, so that's 3. This can't be 3 or 5, so this is 1. The remaining digits in row 6 are 5, 6, and 8. And 5 cannot be either of these cells, so this must be 5. This can't be 6, so this must be 8, which makes that a 6. Rest of the digits in this right central box have to be 2 and 4. It's fine. In the left central box, it's 7 and 9. Column 1, we have remaining digits are 2, 6, 7, 9. But 2 cannot be here, 2 cannot be here, 2 has to be here. Therefore, this is 6, 7, and 9. But because of the 6, 8 pair in the row and the 7 in the row, this can't be 6 or 7. So this is 9, which makes this 7, which makes that 9. That leaves 6 remaining here. In column 2, we have remaining digits as 3, 6, 7, 8. 3 and 8 cannot be here, so they both must be here. This is a 3, 8 pair. But because of the 6, 8 pair in row 2, we can eliminate 6 and 8 in the rest of the row. So this can't be 8. This is 3. This is 8. This has to be then 6 and 7 remaining. In column 3, we're missing 5, 7, and 9. 9 can't be here, so this must be a 9 here. This can't be 7 because of the 7 in the row. So this must be 5. This is 7. The 3 eliminates 3 here. So this is 1 and 9, which makes this a 7. That makes this 9, which makes that 7. In column 4, we are missing 5, 7, and 9 again. This can't be 7 or 9, so this must be 5, and therefore this is a 7-9 pair here. In row 2, we're missing a 2, 4, so that could be 2 or 4 there. In column 5, we are missing 3, 6, and 8, but neither of these can be 3, so this must be a 3 here. This must be a 6, 8 pair here. In column 6, we are missing 2, 4, and 5, but obviously this can't be 5 because of the 5 in the box, so 5 must be here. This must be a 2, 4 pair. Column 7, we're missing 2, 4, and 5 still. This can't be 2 or 5 because the 2 or 5 in the row, so this is 4. This must be 2 or 5. This must be 2 or 5, but it can't be 5 because of the 5 in the row, so this is 2. This is 5. That 2 eliminates 2 here, so it's 4 and 2, which eliminates 2 here, so this is 4 and 6, adding up to 10. This 6 eliminates 6 here, it's 8 and 6, which makes that an 8. This 9 eliminates 9 here, so it's 7, 9. 7 eliminates 7 here, so it's 6 and 7. 6 eliminates 6 here, so it's 8 and 6. We have 2 and 8 remaining here. This can't be 8 because of the 8 in the column, so this is 2. This is 8. The 2 eliminates 2 here, so it's 4 and 2. We have, what digits? 1 and 9 remaining in row 1. This can't be 9 because of the 9 in the row column, so this is 1. This is 9. That leaves this as a 3 and this as a 1. I guess I'm thinking about it. I think the shifter rules are. Is it? I don't know if the shifter lines shift depending on box borders. Maybe? I don't know. It's been a while since I've done shifter lines before, in a while, so I am not sure if that's a normal, if this is a normal constraint of having the digits change depending on when the box borders break the line. Maybe it is. It's been a while. Anyways, I hope you enjoyed this foray into shifter lines and this episode of Learn How to Sudoku. And I will see you next time on Frank Puzzles. Take care.